Hi students, I am Rahamuinissa working as an assistant professor for Vignan Institute of Engineering for Women in Department of CSE. Today in this session we are going to discuss about NFA to DFA conversion. So before knowing the NFA to DFA conversion procedure, let us know what NFA is first. In non-deterministic finite automata, when a state by reading an input symbol, it may reach to more than one state. So that is what non-deterministic finite automata is, where there is no exactness. So in deterministic finite automata, while reaching the another state, it exactly reads a single input symbol and reaches to exactly one state. So that is why it is known as deterministic finite automata, where there is an exactness. So now we will see the tuples which are present in non-deterministic finite automata. A state by reading an input symbol 0, it reaches to more than one state where there is no exactness. This is what we say it as non-deterministic finite automata. Here the state A by reading input symbol 0, it is reaching state A as well as to state B where there is no exactness. Whereas in deterministic finite automata, a state by reading an input symbol 0, it exactly moves to one state. That is what deterministic finite automata, where there is an exactness. And coming to the tuples of deterministic and non-deterministic finite automata are same, where Q, sigma, delta, Q naught and F. So here Q is nothing but the set of states, in the sense that whatever the states which are present in the automata, all those states will be present in this set capital Q, which consists of all the states. And sigma consists of the input symbols. So these input symbols can be either 0, 1 or A, B. So different input symbols can be considered here, where delta is the transition function, and this transition function will differ for both DFA as well as NFA. So in case of deterministic finite automata, here it is mentioned that a state by reading an input symbol 0, a state by reading an input symbol will exactly move to one state. That is what the transition in DFA. Whereas in NFA, the transition function differs. Here we are saying that a state by reading an input symbol 0, it may move to more than one state. That is what here the transition is. A state by reading an input symbol 0, it moves to more than one state. That is represented as the power set. So 2 power Q. This is what the transition function for non-deterministic finite automata. And coming to Q naught is the initial state which will be given in the automata. So there is exactly one initial state where the string or any input string processing will be started from this initial state itself. Whereas F is nothing but the final state. F is final state, and this final state can be either one or more than one final state. So it can be either set of states also. That is why here we say that F is subset of capital Q, whereas this initial state Q belongs to capital Q. So why we are saying it here as F is subset of capital Q means F can be either a single state or else set of states. It can contain more than one states also. That is the reason here we are saying that F is subset of capital Q. Here a string is accepted only if there exists at least one transition path starting at initial and ending at final state. So from initial state to final state, there must be at least one path existing. Then only we can say that the particular string is accepted by the finite automata. So that is what here in the slide it is mentioned what non-deterministic finite automata is. Now let us see the next slide. So in the next slide we are going to see how to convert NFA to DFA. So till now we have learned what DFA is and what NFA is. Now we are going to see the conversion. So let us take an example and solve this. So this is what the NFA given. This NFA has to be converted to DFA. So why we are saying it as an NFA? Here the input symbol is A. Q naught, by reading an input symbol A, it is reaching to Q naught, whereas it means to the single state. Whereas Q naught, by reading the input symbol B, it is staying in Q naught as well as it is moving to Q1. This is what the non-deterministic finite automata is. This transition where a state by reading a single input symbol moving to two states gives the non-determinism where there is no exactness, and this Q1 is reaching the final state Q2 by reading the input symbol B. So first let us see the procedure and then come back here to solve the problem. So here first step what we need to do is let Q dash be a new set of states of the deterministic finite automata. So anyhow we know that NFA is going to contain Q is nothing but the set of states which are available. So capital Q is nothing but a set of states of NFA. But as now we are going to convert this NFA to DFA, so the set of states in DFA are represented by Q dash. So let Q dash be a new set of states of deterministic finite automata and T dash be a transition table for the DFA. So from the given question, first we need to construct a transition table. That transition table is nothing but the NFA transition table represented by T. But here we are going to consider T dash as the new transition table for DFA. So Q dash is nothing but the set of states of DFA and T dash is the transition table of DFA. And in the next step we are going to add the transitions of the start state Q naught to the transition table T dash. So as we have seen in the previous step that we are going to construct a transition table, and in this transition table what is the first entry that should contain? So the first entry should contain the initial state. So we need to start from the initial state. So we have to write initial state by reading the input symbol 0 and input symbol 1 or input symbol A or input symbol B where it is reaching. So that is what we are going to write here. New state present in the state Q dash is Q naught Q1. So here by reading an input symbol A, Q naught state by reading input symbol A, suppose if it is reaching to state Q1, and Q naught by reading an input symbol B if it is reaching to the state Q naught Q1. New state present in the state Q dash is Q naught Q1. So here the new states are Q naught Q1 and Q1 is also a new state here. So now next we need to construct for Q1 as well as Q naught Q1. So in this way, whatever the states, new states appearing under the input symbols A and B, for those new states we need to find out the transition in the further steps. So this procedure is going to continue as well as there are no other new states present in the transition table T dash. So this method which we are constructing new state each time is nothing but subset construction method. So we can say that in order to convert NFA to DFA, subset construction method plays the vital role in the conversion. So here in step 3, new state present in Q dash is Q0, Q1 as well as Q1 here. So we have not yet solved the example. This is just we are seeing the steps how to solve it. So here the new steps will be considered in the further steps, and the entries for those will be written in the transition table T dash. Add transitions for the set of states. So whatever the new states which are appearing here, for those transition, the entries or the entries under A and B will be written in the transition table T dash. So here in such a way, whatever the new states which are present in the transition table which are appearing under the input symbols A and B are going to be considered each time. Add transition for set of states Q0, Q1, Q2 to the transition table T dash. So this Q0, Q1, Q2 is another new state for which again the transition has to be found out. So by considering this Q0, Q1, Q2 as the new state, we are going to again find the entries for this Q0, Q1, Q2 state under the input symbol A and under the input symbol B in the transition table T dash. In the next step, since no new states are left to be added in the transition table T dash, so we stop. So we do continue this procedure until we find no more new states in the transition table T dash. So states containing Q2 as its component are treated as the final state. Now coming to the next point is deciding of the final state. So we know that the initial state which is mentioned in the NFA will be treated as the same initial state in DFA 2. Now we need to decide the final state in DFA. So final state in DFA, whatever the final state which is mentioned in NFA. So suppose if Q2 is the final state in NFA, here in DFA, in whichever set or wherever you find Q2, that state is completely considered as the final state in DFA. So this is the step 5. So finally we are going to obtain a transition table. This is the transition table T dash for the DFA, where a state by reading an input symbol reaches to exactly one state. Now here, though Q0, Q1 are two different states, here they are considered as the single state. So now our new states will be Q0, Q0, Q1, Q0, Q1, Q2. So these are the new states, and by considering this, we are going to construct the DFA. Now let us solve this problem. So here this is a non-deterministic finite automata, and this NFA has to be converted to DFA. So first step, we need to consider the transition table T for NFA. So the states here are Q0, Q1, Q2. So Q2 is the final state, Q0 is the initial state, and A and B are the input symbols. So Q0, by reading an input symbol A, it reaches to Q0, and Q0 by reading input symbol B, it is reaching Q0, Q1. So this, by this it is given as an NFA. Whereas Q1, by reading an input symbol A, it doesn't have any transition, so keep it as 5. And Q1, by reading an input symbol B, it reaches to the final state Q2. Whereas Q2, by reading input symbol A and B, it doesn't have any transition, so keep it as 5. So the first step is we need to construct the transition table from the given non-deterministic finite automata. From this, now we are going to apply the subset construction method. Now let us take another transition table for deterministic finite automata as T dash. So here it consists of the states, and the input symbols A and B. So as we have seen in the steps that the first entry in the transition table T dash will be the starting or initial state. So Q0 is the initial state given in the question, and the same Q0 will be carry forwarded in the transition table T dash 2. So Q0, by reading an input symbol A, it reaches to Q0, and Q0 by reading an input symbol B, it reaches to Q0 Q1. Here if we observe, Q0 is already an existing state, whereas Q0 Q1 is now considered as a single state, and it is the new state. Now this new state will be considered as the next entry. Q0 Q1 is the new state. Now we need to find out the entries by reading the input symbol A and B for the new state Q0 Q1. So Q0 symbol by reading an input symbol A, it goes to Q0, and Q1 by reading an input symbol A, it goes to it doesn't have any transition, so phi is written. Now we need to apply union for these two entries. So when we perform union, the state which we obtain here is Q0. Similarly, we need to write what this new state Q0 and Q1 by reading the input symbol B gives. Q0 by reading input symbol B, it gives Q0 Q1, whereas Q1 by reading input symbol B, it gives Q2. Now we need to perform union for this two entries. So the final state is Q0 Q1 Q2. So here if we observe, again we obtained here Q0, which is already existing state, so it is not a new state. Now here Q0 Q1 Q2 is considered as a single state, and it is the new state. Now we need to find the entry for Q0 Q1 Q2, the same procedure which we applied here. So Q0 by reading an input symbol A, Q0 by reading an input symbol A, it is going to Q0, and Q1 by reading an input symbol A, it doesn't move anywhere, it doesn't have any transition, so phi is written, and Q2 by reading an input symbol A, it doesn't have any transition, so phi is written here. So apply union operation for these three entries. Now we are going to get here as Q0. So Q0 is the entry which we obtained here by reading the input symbol A. Similarly, we need to find out Q0, Q1, Q2 by reading an input symbol B. So these are the entries for the input symbol B. So find out the union operation. So here Q0, Q1, Q2 is the entry. So here if we observe, we don't get any more new states, so we need to stop the procedure here. This procedure is nothing but the subset construction method. Now coming to the decision of the final state, we have told that wherever the final state Q2 is present, that will be the final state in deterministic finite automata. So if we observe, we don't have Q2 here and here we are having the Q2, this will be the final state. So now let us see the final state diagram. Yeah, this is the final state diagram. Now the new states are Q0, Q0 Q1 and Q0 Q1 Q2. So this will be the final state because Q2 is present here. So this is how, by considering the transition table T, we are going to draw the transitions. So this is how we are going to convert non-deterministic finite automata to deterministic finite automata. Thank you all.